Does it make sense or not? You all sure? Okay. All right, we're going to use that. Don't forget it, it's going to become very helpful later. All right, let's see, this one from the book. Yeah, let's do this one. I'm going to have to break open the book for this one. Okay, so I'm gonna write this down on the board just the way it appears in the book, and I'm not gonna write it right here. I'm gonna write it on the side. I'll put it over here because I think it's important for you to see that the way it's worded. So it says, find the volume of the given solid. Okay, here it is. It's the solid bounded by the cylinder y squared plus z squared equals 4, and the planes oh, wait a minute, hold on. Yeah, x equals 2y, x equals 0, z equals 0 in the first octant. All right, so that's the way the problem appears in the book. So imagine this is the way a problem would appear like on a test. Except I would say find the formula for the volume, do not evaluate the integral. So I won't ask you to go the whole way with it, but I will expect you to set it up. All right, so we need to get an idea of what this thing looks like, right? So x equals 0, z equals 0. I think we might be able to start there. X is 0 is the YZ plane. So that's this back wall. I'm going to do it very lightly. This is the back wall, right? We're in the first octant, right? So that means I'm not going to look at anything over here, right? Everything past there. Okay, how about x is 0 we got. Z is 0 is the ground, right? Z equals 0 is the ground, so we've got the ground in here. All right. So these are boundaries. These things are forming boundaries of this solid. Should we do x equals 2y? You want to do that one? We just did that one, didn't we?
Yeah.
And that looked like this. It was like here was 0, 0, and then when we came out 1, 2 on the x, right? The y was out 1 unit. So it looked something like this. So that was it on the ground, right?
Yeah.
But it continues, it keeps going. So we got this plane, and this just gets kind of hard to draw, okay? Got this like plane that's vertically cutting through. Is this already looking like a disaster? It kind of looks like a disaster to me already, yeah. Okay, so we've got kind of like this boundary wall, the ground, and then this. So ground, this, and like some boundary here. So we need one more thing here, close it up. The cylinder, y squared plus z squared equals 4. So that's a cylinder of radius 2 that opens which way? Which way does that thing go? Down which axis? Is it a beer can up and down, or is it spilled beer can down the x-axis? Right? Because the x is free. There's no x in there. So you can imagine like this beer can going through like this now? Okay. We're just trying to find the volume of the solid bounded by all those. No problem? Crap. So where does this cylinder hit the y-axis right here? At 2, right? At 2 because the radius is 2. Where does it hit the z-axis? At 2 also. And so between there and there, it should look like this, shouldn't it? So on that back wall, that can hits like this, doesn't it? And then you got the floor right here. You got the surface of the can. Man, it gets hard to draw. That edge is part of our solid, isn't it? This plane is cutting through our can. That plane right there is cutting through our can, right?
Yeah.
My perspective sucks on this. I need to be able to turn this a little bit because it's hard to draw it like this. So what do you want to do? This is the challenge. I mean, this is part of the challenge for you is can you get a good visualization of what you're trying to do? I mean, I could just bring the damn computer up, but that doesn't help you when you're sitting there trying to take a test, right? Here's the cylinder, right? Here's x equals 0, the back wall. Here's z equals 0, that's the ground. Here's x equals 2y. We're talking about that solid right there. Take all that crap out of here. That's what we want.
Yes.
Okay? That's what we want. We want the volume of that solid. So this is the human way of trying to draw that picture, right? So we have to do our best. So I think the hard part is maybe this piece right here. This is why I don't like the perspective. This should be a curve right here from where it's hitting the plane. That's curved. It's not straight because the plane comes straight, but this is curved. All right. Do you think that's enough for us to move on? Okay, so can we look at this as a surface on top and a region on the bottom? Yeah, I think this cylinder should be our surface, shouldn't it? So all we have to do is take that equation, solve it for z. If we solve it for z, we should get, plus or minus, right? Square root. But we are only going to be worried about the bottom, the top, the plus, because we're looking in the first octant, right? So that's our surface. That creates this. And now we need the region on the ground. So where is it on the ground? I think we should draw it. Let's draw our x and our y here. We know we have this. That goes out 2 and goes over 1, right? And our cylinder comes through here. No. Was that 2? That was y is a half x, right?
Yes.
So that is the right thing. So actually it's going to be out here at 4, right? 4 to 2. This is where my cylinder comes through, right?
Yeah.
You'll see that?
Yes.
So that's this right here is this piece right here. What type region is that? Either way, you can go either way with this one, can't you? I'm going to just stick with type 1 because type 1, my rectangles are going in like this. My top and bottom functions are pretty clear. And my limits of integration are pretty clear also. Y'all okay how I'm getting 4 here? Because 4 goes in, you spit out 2, but then that'll hit the radius. So here we should be able to go x and y. X is between what? 0 to 4. And then my y's, well, I know my top one is 2, right? And the bottom one is this line, which is half of x. And that's it. We can set up the double integral now. All right, so the double integral will be going from 0 to 4, going from 1/2 x to 2, and we're integrating that square root of 4 minus y squared dy dx. Now, do you feel like that's an integral you'll be able to do? 4 minus y squared with respect to y? How would you do that? I heard it. Trig sub. There's actually a formula in the back of the book for it also, but like trig sub would be the way to go after that one. So that's a doable integral. At least the inner integral is doable. You'd have to see what was left after that, but it might be worth it to switch the order of integration here, because if you switch it, if this is with respect to x first, then that's going to be very easy to do. And then on that next step through, you're probably going to be able to do basic u sub on that. But you just have to play with it. All right, I'm going to give you one now, and I'm going to let you set it up. Okay? See how y'all do with it. So let me see here. I want to do 24 from the book. Let me take a look at 24. You know that little note that I gave you about the area? Like if you do the double integral of 1? Yes. Okay, like I showed that to you and then I haven't said anything else about it, right? Right. Okay, just back burner that, all right? Okay. Back burner it. It'll come up again. It's an important note. It's in the section. We're going to use it later. But it has really nothing to do with this problem and the one I'm giving you, all right? But I don't want you to forget about it, all right? All right, so here's the one I'd like for you to do. See if you can set it up. So this is really trying to get used to translating this stuff, right? So same thing, find the volume of this solid bounded by, enclosed by the paraboloid z equals x squared plus y squared. Oh, sorry, 3y squared. X squared plus 3y squared. X equals 0. Y equals 1, y equals x, and z equals 0. So see if you can draw that and then try and figure out what the surface is, what the region on the ground is. Talk to each other, help each other, do the best you can, all right? And I think I'll give you like, I don't know, you don't have to take it the whole way. I just want the integral set up, all right? Let's see how you do in 10 minutes. Try and get a decent drawing of it.
That's 24 on the book?